We live in a world where we're surrounded by lists. You have contact lists, to-do lists, grocery lists, lists of friends that you're following on Instagram, and so on. Well, how can we model lists in a Python program? In order to do that, we're going to make use of the list data type. It's perhaps one of the most commonly used data structures in programming. So let's get started with some common syntax and how do we even declare a variable of type list of strings or list of integers. Well, the type of a list is specified with lowercase list, and then we're going to see some square brackets, and then inside of this list we'll have, I'm going to write a capital T, where T is the type of list. T is the type of item in our lists. Okay, so let's start with, what if we wanted to have a list of names? Well, we would have a list of strings. So for example, we could have a list of str. And that's a data type. So because that's a data type, we could declare a variable, say, let's call this variable names, to be of type list str. Well, how do we actually use this type and initialize it? Well, let's say we wanted to initially have an empty list of names. In order to do that, we could have, we've got a couple of options. One is the list constructor, and we call the list what looks like a list function, but this is a constructor of the list data type, and this will construct an empty list. So this is how we would declare a variable. And this is how we would initialize, I'm going to move this down just a little bit, an empty list. So when our list is initially constructed, it's going to have 0 items in it. I think this might actually be nice to play around with in VS Code. So I'm going to just flip back and forth between our notes that I encourage you to take as you're following along, because getting some familiar with the syntax is important, as well as an example that we can follow in VS Code. So in VS Code, I've gone ahead and set up in my lessons directory a lists.py example, and we're going to have some examples here. And we're also going to have this, I'm going to have this loaded in Trailhead and the REPL opened to it. And let's go ahead and try declaring this. So names is, say, list of str, and it's going to be initialized to list. Right? So when we save this, notice that we have in our globals frame this variable name, and it's currently an empty list. Right? Well, pretty quickly we would like to be able to add some items to it. So how can we add items to a list? We have a special method of this list object. So it's been a while since we've talked about methods. We introduced this type of expression a few weeks ago, but names.append, and let's just say, you can drop in your first name here. So I'm going to append my first name, Chris, and when I save this and jump back over, you'll notice we have this names list, and if I were to click on this, we would see that at index 0, we have the name string Chris. Okay. This syntax that we're seeing here, the open square bracket and the closing square bracket, we'll come to learn as a list literal. We'll come back to this, right? But for good measure, let's add additional names. So I could also add, say, the name Mara to this list. And maybe you could add your friend's name or your parent's name or something like that. And notice that by appending, we're adding another item onto the end of our list. Let's just break down this particular syntax really quickly. And I'm going to jump back over to notes in order to do so. So common operations. Add items to list. And so to add an item, we will use the list name. So here we have names. And then in red, I'm going to have the method .append, and then the item value. And so this is how we're able to add an item on to the end of a list data structure. One of the important things to know about a list is that it's mutable, meaning we can change the list or the contents of the list, the items that the list contains after the list has been set up. We'll soon see there are some other data types which are what we would call immutable, and you have to construct them with their initial values and you can't change them later. But list is mutable, and one of the ways that we can add items is with the append method. All right. And how can we access items? So back over in VS Code, we can continue on with some of our notes here. So add items to a list. And now we will access items in a list. So what if we wanted to print each of the names in this list? Well, we could do this with a while loop, or we could do this individually. So for now, let's just go ahead and do names, subscription notation, and not I, but let's say 0. So we can access items using subscription notation. 0 indexed, just like with strings, where we can access characters of the sequence using subscription notation. With lists, we can access values in this way. So you'll notice that when I save this, we see Chris is printed out down here. If I were to go to the Run tab, we would see that when this program is run, Chris is here. We haven't spent much time declaring variables in the global frame, but I'm doing this here because it makes it easy to play with globals in our REPL. For example, if I were to try and evaluate what's at names index 1, we see that that's the string Mara. I should point out something that we've kind of glossed over at this point, which is what's the difference between printing in the REPL and just evaluating an expression in the REPL. So notice if I were to print names index 1, we see that we get this type of output. So when you print something, it's just plain output sent to the user. But because we're in the REPL, and part of the REPL's functionality is this print step. So we read what's the expression, we evaluate it, that's Python is interpreting this part of our expression, and then the REPL will automatically print on your behalf. So that's why we can do things like names index 0. And in Trailhead, we see that there's this special highlighting that's saying, you know, this wasn't actually output. This wouldn't, if we had this line in our program, we wouldn't see it. But because it's been evaluated, we see it evaluated and automatically printed as the result of this expression. Another thing we can do, and one of the things that's fun about playing around in this REPL, is we can also do things like name.append and let's say Lewis. And notice that we can see in globals that now at index 2, we have Lewis up here. And so the REPL gives us a way of playing around with variables that we perhaps initialized in our example file. Okay. What else might we want to do? Well, maybe we want to remove names. So remove items from a list. And this has a funny terminology called pop. So names.pop. And then we give an index. And so the index that I could give here is, let's say we wanted to pop our name off of this list, so we could do that. And so on line 15 we say, okay, well, we printed off Chris from line 12, and then we popped Chris, so that by the time we get into evaluating this, if we were to print names 0 again, we would see that that was the second item before. And this brings about an important thing to realize. When you pop an item from a list, it ensures that the indices still are starting from 0 and counting up by 1 for each subsequent item in the list. This is an important property of what makes something a sequence. This also has the effect of being actually kind of expensive. And if you can imagine why, well, if you've got your items in memory and you pop one here, in order for this to all work out, Python's going to have to move every single item that came after it up by 1, up by 1, up by 1, up by 1 until the very end. We're not too concerned about performance in this course. The next course in computer science goes very deep and cares significantly about performance concerns. But I just want to mention that because there is a cost to popping something and having to shift everything else up. So let's jump back to our notes and make sure that we've got notes on these two operations as well. So access items. The way that we access items is with subscription notation. So here we have names, and then we use subscription notation. And in this subscription notation, I'm going to write an expr of type int. And this is important. This is one of the big ideas of sequences in this particular syntax. Because we can use an expression of type int here, that means we can use an integer variable. And that's what's going to allow us to write a loop that iterates over each index in our list and prints out its value, right? Or accesses its value to do some computation with it. Cool. Additionally, we looked at remove items. And this has a special method named pop. And I'll write this method in red. And the index is what we specify as the argument here to indicate which index is being removed. Now, one of the things that's actually kind of interesting, we didn't see in our example, right? Because we popped, and I'm going to jump back over here. We popped index 0, and we didn't do anything with this method call. And then we printed name 0. Well, let's try popping names 0 again. And based on what we've just learned, so names.pop index 0, notice that this actually was a method call that evaluated to the item that was removed from our list. So when we remove an item, I'm going to make a little note of this, pop evaluates to, and let me change back over to notes, evaluates to the popped item. And that can be very handy because you pop an item off your list and now you have access to it. And if you didn't care about accessing the items of your list after you'd worked through some processing, you could just pop each one off from the back end of the list one by one and work with each item. And at the end, you would have an empty list and you wouldn't have to access them directly. You could just pop, its returned value would be accessible, but it does destroy your list. You would have an empty list by the end of it. Okay. So what else might we want to be able to do? Well, we probably, if we're going to write a loop that's going to iterate over each index in a list, we probably need to know how many elements this list has. So we can access the length of a list, which tells you how many elements or items that list contains, with the len function that's built into Python. So this is how Python carries this out. So len of names will tell you how many items are in the list. And let me actually make a note of that, which is how many items. You'll hear me use the word items in a list or elements in a list interchangeably. And I'm just talking about, we have a list data structure that contains all of these items, but each individual item we would refer to as an item or an element in standard terminology. Okay, so why don't we try iterating over another list? And let's try in VS Code, adding another example here where we can, let's see, I didn't leave a note here, so declare a variable of type list of strings. Okay. And maybe we add one more variable down here at the bottom, which is declare a variable of type list of integers. So maybe we have a variable named nums or numbers, and it's a list of int. And perhaps we just choose some numbers like 110, 210, 301. Maybe I'll throw in 211. And 311. These were just the first numbers that came to mind. These are course numbers in computer science that if you were to continue on, but we're just going to treat these as opaque numbers that we don't actually care what their significance is outside of just having these values. So if we were to reload our REPL, notice that back in Trailhead now after saving, once this file had reached line 20, if we wanted to keep playing with these values, we now have names and numbers has 5 elements in it. So if we wanted to test this len function, we could do len of numbers, and we see that that would evaluate to 5, and len of names, of course, is 1. because there's only one element in the names list after our programs reach this point, 5 in numbers. Cool. So let's try writing a while loop that sums all of these numbers up. So we can keep track of total as an int value that is 0, and say an IDX value that also starts from 0. And while IDX is less than the length of numbers, this is our pattern that we learned very recently on how do we iterate over a list of, or a sequence of numbers starting from 0 up to n. Well, we start from 0 and we use the less than symbol in the upper extremity, the length of our numbers, as our terminal. And we always have to be sure that we are increasing our counter variable. So IDX is IDX plus 1. And how are we increasing this total? Total is the current total added to numbers at index IDX. Okay. And so if I were to save this and just check my work here, we'd see total is 1,143 after this has completed. And so if we were to add these numbers up, that's what we would get. The big idea here is using these two characteristics, these two abilities with lists. We can use the length of a list to know how long, how many times that our loop needs to iterate so that we check each item one by one, and we keep track of an index. Because we're able to use this subscription notation here, numbers at index IDX, and use that to access each item one by one, using this pattern of writing a loop that loops from 0 to 1 less than some high-end number, we can iterate over each item in our list. And that's very powerful because we can write algorithms that here in these 3 lines or 4 lines of code, 5 lines of code, we are summing these values. And it doesn't matter if we were to add more items here. So I'll add 1,000 to this. So we expect once this saves that, yeah, 2,143 was added. And so that summed it up. So this list could be 1,000, 1,000,000 line elements long, and this single algorithm for summation would carry out this algorithm no matter how long, using a fixed sequence number of instructions in our program. So that's a cool little algorithm there. I would be amiss not to mention that summation is something that's so common in Python that it has a built-in function. So there's a sum function. If we were to see what is sum, we see that it's a built-in function named sum. So sum of numbers we see is 1,143, and we can check that our work, yeah, total, that's what we had received as the result there. So our little implementation here was correct. The point of this example is we are able to use subscription notation in order to access a specific index. Now, there's one other example I want to pose to you all that is a little bit confusing the first time you see it, but we'll explore this in an upcoming video on how to diagram this and demystify it. But let's go ahead and add one more example here called list references .py. All right. And an example of lists as references. And in this example, I actually want to show you all one more. Actually, I glossed over this. So before we go on to lists as references, I need to address what is this syntax here, and we should make some notes on this. So this is what we would call list literal syntax. Notice that I didn't start an empty list and append items to it. In my code, if I knew the numbers that I was adding to a list directly, you can use an open square bracket and a closing square bracket, and then list out the item literals, or these are expressions. So if we had variables here that were integer type, we could use variables as well. But this allowed me to establish a list with these items in it without having to append them directly. And so this is a very common strategy for working with a list. So for example, if we also had, say, a list of prices, that would be a list of float, and we could assign using this list literal syntax $10, $20, and $1.93. we could see up here that prices is this list. Here are its values. And again, the sum function will work with this as well. So sum of prices, the built-in sum will add those up for us. So let's actually make some notes on this. I don't want to gloss over this before we talk about references. And let's go ahead and add a note for list literals. And a list literal is an open square bracket followed by, a closing square bracket that has to match. And in here we have, item 0, ... I'm going to use the ellipses there to allude to we can have any number of items and maybe n. And so if we wanted to add, 5 items, we would have item 0, 1, 2, 3, 4, and 4 would be our last, because then we would have 5 starting from 0. So this actually is a little bit easier with an example. So for example, we could use 0, 1, 2, or an empty list. So we can specify an empty list as well. And I'm going to make a note that this is the empty list. Now, this is a little bit interesting in that we're now seeing multiple places where we can use square brackets. And it's worth just differentiating these places and being sure that there's no confusion. So let's add a few more notes here. Places, syntactic uses of square brackets. So our first example of this that we saw earlier in the course was subscription notation. And this applies to working with lists too. So with a string, let's say, hello, we could use subscription notation, which I'm going to write in green. So here's the green square brackets and some index, which maybe I'll write, 0, right? So this was an int expression. That's one place where we've seen this. It turns out we can combine this with, or we use this with lists as well. Any place actually where we have a sequence, we tend to be able to use this syntax. We'll learn that we can use this in conjunction with another data type that's not a sequence in an upcoming lesson. So the second place that we saw this was actually earlier today, where we declared the type of our variable. So list of string here. And so what we're seeing here is, notice that we've got square brackets here that are as part of our type declaration, right? So we're declaring that this type is list, and then we use the square brackets in this style to mean some specific type, right? So here we're going to say, and this is technically called generic typing, but I'll just call this type specification. And this is where we would have something such as, list. And then we would have, I'm going to use square brackets here in dark blue to be something different. This is a different meaning of the square brackets. And then here we would have, say, T, where T is type. For example, list of str. Right, so we would have a list of strings. And the most recent usage that we just saw was list literal notation. And so a list literal allows us to construct a list with items initially in it. And I'll use the lighter blue here. So this would be a list and the close of it. And this is where we just learned, I'm going to write item 0 separated by a comma, and then item n, right? So we can have our items, and this establishes a a list with some initial values in it. So notice that we have these three different uses of square brackets, and it's important to realize, which of these you're working with. And if we wanted to really have a little bit of fun with this, we could actually use all three of these in a single statement. So how might that look? Well, let's imagine we had a variable like, say, x's, which is a list of int. And actually, this is gonna to use all three of these in one line. I'm gonna have to be a little bit creative here. We can say x of 0, 1, and 2. And this has the two uses, which two are these. Well, if we were to break this down syntactically, this is the type, and this is the list literal. How would we use subscription notation here? Well, we'd have to do something so tricky that I don't want to show it to you. So let me just make use of this on, let me show you a different line that has both of these, two additional uses all in one. So we could also do something like print and then have a list literal 0, 1. Let me use ABC here. A, B, and C. So you can have a list literal like this, that's a string list. And we could use index, say, 1 here. And if we evaluated this, we could go try this out actually. We would see that this subscription notation, just like where we can use subscription notation with a string and access character 0, that's the H here, we can use subscription notation off of a list literal, and index 1 would be, the string B. So if we wanted to prove to ourselves that this is the case, we could do something like, here's my list literal A, B, and C, right? There's the list, but if I were to access index 1, like the example showed, we see that that's just the string B. So be careful in differentiating these three different uses of the square brackets. I'm actually going to leave the example that I'm going to leave you all with a bit of a cliffhanger here, and that is list references. And we'll get to the bottom of this in an upcoming video, but let's try something out really quickly to set the stage. So let's imagine we have a list A, list of stirs, and let's just say it's, we'll use our list literal syntax here. It's A, B, and C. And let's say B is a list of stir. That is the same list as A. And oops, let me go back and let's go back to list references here. And we see, okay, we've got these two lists. Now, my question to you is, what happens if we append to list B? So B dot append, and then let's try something like exclamation points, maybe some exclamation points and some question marks. And I want you to try evaluating this. I'm not going to spoil it here, but before you do, ask yourself what you think would happen in this scenario. What do you expect would happen based on what we've learned so far? And in the next video, we'll get to the bottom of why does it maybe not work quite the way you would expect and what's going on under the hood. Great work in this introduction to lists.